This second Scalativity episode explains the cosmic microwave background radiation according to Fractal Big Bang Theory. There are fundamental differences between Fractal Big Bang Theory and Standard Big Bang Theory. One theory matches reality, the other does not. The vast majority of scientists today currently believe Standard Big Bang Theory matches reality. Fair enough. But does it? Does it really? You should want to know. Governments allocate billions of taxpayer dollars to fund scientific research. That money should be spent wisely. Can experiments distinguish between Fractal Big Bang Theory and Standard Big Bang Theory? Yes, absolutely. Quickly and cost-effectively. We have the technology to challenge a major pillar supporting Standard Big Bang Theory. Will anyone out there have the courage to conduct the experiments? That is the question. Modern physics claims the measured cosmic microwave background radiation was emitted over 13 billion years ago when matter and radiation decoupled, was emitted at a temperature of about 2700 Kelvin, had its wavelength stretched by space as space itself stretched, and now corresponds to a temperature of 2.7 Kelvin. Fractal physics claims the measured cosmic microwave background radiation was emitted from a few days to several weeks ago, not billions of years ago, was emitted at a temperature of 2.7 Kelvin from the surface of cold dark stars, not at 2700 Kelvin, did not have its wavelength stretched by space, nor does space itself stretch. Familiar hot bright stars are composed mostly of hydrogen and helium. If our sun's surface was at 2.7 Kelvin, it would be a cold dark star radiating a perfect black body spectrum, exactly like that of the cosmic microwave background. On Earth, at a pressure of 1 atmosphere and a temperature of 2.7 Kelvin, all the elements of the periodic chart are solid in form, except helium, which is liquid. Liquid helium boils at 4.2 Kelvin at 1 atmosphere of pressure. Liquid helium boils at 2.7 Kelvin at 0.15 atmospheres of vapor pressure. Liquid helium boiling on cold, dark stars generates the cosmic microwave background. 3 mission satellites measured this cosmic microwave background with increasing precision, namely COBE, WMAP, and Planck. The average temperature is 2.725 Kelvin, with minute deviations. Some parts of space are slightly warmer, while other parts of space are slightly colder than 2.725 Kelvin. Standard Big Bang Theory claims these temperature differences seeded the formation of galaxies. Fractal Big Bang Theory claims these temperature differences are due to the Doppler effect from the motion of nearby cold dark stars. The Doppler effect implies relative velocities between 1 and 3 kilometers per second. Neutrons are everywhere inside newly formed nuclear explosion particles, including thermal neutrons that travel at 2.2 kilometers per second. In fractal physics theory, an object's velocity is independent of its scale. Therefore, cosmic scale neutrons are traveling from 2 to 3 kilometers per second in the solar neighborhood. The Milky Way galaxy is mostly cosmic scale uranium dioxide, recently crystallized around a positively charged cosmic scale fission product. Cosmic scale oxygen is also expected to have a vibrational velocity near 1 kilometer per second. Cold dark stars emit the cosmic microwave background at 2.725 Kelvin, with temperature variations indicating their velocity. The cosmic microwave background power spectrum plots temperature differences versus angular separation on the sky. These temperature differences occur at scales corresponding to cold dark star diameters. Additionally, the cosmic microwave background photon density correlates to the total surface area of cosmic scale nuclei in the solar neighborhood. Experiments can detect these cold dark stars within weeks. Radar astronomers observe astronomical objects by reflecting microwaves off these objects, detecting their echoes. This research has been conducted for 6 decades. If cosmic microwave background data acquired by COBE, WMAP, and Planck is reinterpreted with fractal Big Bang theory, then radar astronomy microwaves aimed at appropriate cosmic microwave background temperature differences will echo detect nearby cold dark stars. 10 astronomical units is about 1/4 of the distance from the Sun to Pluto. To detect the echo from an object 10 astronomical units away, the object must be a few hundred kilometers across. As a consequence, radar astronomy operates within the confines of the solar system. However, cosmic scale nuclei are predicted to have diameters ranging from 750,000 to 6 million kilometers. If the solar neighborhood is a titanic scale solid, then a few cosmic scale nuclei are within 1,400 astronomical units. Cold dark stars are large enough and close enough to be detected by today's radar astronomer. If standard Big Bang theory is correct, then to detect these echoes would be like shooting a cannonball at a piece of tissue paper and having the cannonball bounce back and hit you. Let us petition the 2 radar astronomy facilities, Arecibo Planetary Radar and Goldstone Solar System Radar, to perform these paradigm-changing experiments. Occam's razor is a principle of simplicity used in logic and problem solving. It is often used to compare competing theories. The simpler explanation is often considered better, especially if it can explain more phenomena. Fractal Big Bang theory unites the cosmic microwave background with dark matter. Therefore, it is simpler than standard Big Bang theory. Cold dark stars absorb incoming starlight on their surface and radiate the cosmic microwave background. Cold dark stars act as ultra-cold mirrors, radiating back the sun's photons to COBE, WMAP, Planck, and any other detectors. For as long as scientists have seen the cosmic microwave background, they have seen dark stars. Fractal Big Bang theory has far greater explanatory power than standard Big Bang theory. But more important, fractal Big Bang theory can be tested by experiments. Great claims require even greater evidence. Dr. Michael Nolan and Dr. Martin Slade, please echo detect this dark matter for all of us and begin the transition to the new scientific paradigm, fractal physics theory. This episode was produced by Z23 Studios. Remember to subscribe to our Scalativity channel so that you never miss an episode. Please go to scalativity.com to read the 5 initial fractal physics theory articles published online in the Fundamental Journal of Modern Physics. Scalativity.com also offers 3 groundbreaking articles available nowhere else. Until the next episode, this is Leonard Malinowski, inviting you to help me advance physics.